Okay, let's take a look at a couple of examples of this mole concept. So here are some examples. It wants us to figure out how many atoms of hydrogen are in 3.26 moles of ammonium chloride. It's a little sloppy. Okay, this is a unit conversion problem, so start it out like you always do, with what you know in the first bracket. And now here, it is important that you label what you have moles of. So yes, it is tedious to write this out every time, but it's a good habit to get into. In a little bit, you'll see why. Okay, so we're looking for atoms. So first we need to convert from moles of our compound to moles of our hydrogen. So how many moles of hydrogen are in this compound? All you do is look at the formula. There are 4 moles. And then in the last bracket, we're going to use Avogadro's number to convert to number of atoms. And doing the math there will give you the correct answer. 3.26 times 4 times Avogadro's number yields an answer of 7.853 times 10 to the 24. What's your unit? Atoms of hydrogen. It's a math problem. Whenever you get done, ask yourself if you have the right number of sig figs. Do I have the right number of sig figs? No. You have to go by what you're given here. This is an exact number, and this is an exact number. So there are 3 sig figs here. That means my answer can only have 3. Alrighty, let's take a look at the number 2. How many atoms of oxygen are in 36.1 moles of aluminum carbonate? This is basically the same type of problem as above, so I want you to pause it and try to see if you can get this right answer. So I'm going to start out with what I know. Now here you need to convert from moles of compound to moles of oxygen. How many moles of oxygen are in this compound? It's not 6. It's not 3. This should be 3 times 3. So you should have 9 moles of oxygen and 1 mole of your compound. And then we're looking for number of atoms, so we use Avogadro's number per 1 mole. And that'll give us an answer, 36.1 times 9. How many sig figs should you have in the answer? 3. 1.96 times 10 to the 26 atoms oxygen. If you don't label what you have atoms of, I will mark it wrong for an incorrect label. So it must be atoms of oxygen, just as here you had atoms of hydrogen. Oh. Okay, now if you turn to page 133 in your text, there are some really great example problems. In the kind of gray brackets or gray boxes, there's an example problem. It gives you a question. It takes you all through how to solve the problem. And then it gives you another problem that's very similar to the example problem for you to practice. I highly recommend going through all of the examples in all of the sections that I'm talking about in class. The more example problems, the more homework problems, the more practice problems that you can do on your own and look at other people's work in the book, the better you'll get at these concepts. Okay, So the question 5.3 in the book asks, we wish to weigh 2.84 moles of sodium sulfide. How many grams is this? Okay, so this is, oh shucks. I'm sorry, example 5.2 first. A person drinks 1,500 grams of water per day. How many moles is this? Okay, so this is all it is a unit conversion problem, so set it up the way you always do. What you know on top. Okay, now we need to go from grams to moles here in this problem. There's only one way to go from grams to moles, and that's using your molecular weight. Do you remember how to calculate molecular weight? All you have to do is add up the mass numbers of each element from the periodic table. So here you're going to have to calculate the molecular weight of water. So you're just going to add 15.99 plus 2 times 1.01, and that gives you an answer of molecular weight of water, here I'll just write is 18.01 grams per mole. Do not write 18.01 grams on the top line of the next bracket. You have to cancel grams out. And here, this unit really means grams per 1 mole. So, in order to get your grams to cancel out, they have to be on opposite sides of your fraction. Grams here has to be on the bottom. Therefore, 18.01 also goes on the bottom. When you're using molecular weight in a unit conversions problem, the number you calculate always goes with the unit grams. Write that down and highlight it. The number you calculate always goes with the gram, not the mole part. Conversely, molecular weight is always calculated per 1 mole. Therefore, this number always has to be 1. We're going to get to why this is important a little bit later on. But you're never going to put 18.01 grams per 2 moles, per 3 moles, per 4 moles. That's always per 1 mole. We'll get to that in a little bit, but write this stuff down. Okay. Back to our problem. This is per 1 mole. Now, after you cancel out your units, do you have the unit you're looking for? So then just do the math. 1,500 divided by 18.01 equals 83 moles. You should only have 2 sig figs. There's no decimal point there. Therefore, those 2 zeros are not significant. That confuses you. Go back and look at lecture 1.1. So your answer is 83 moles. Okay, let's now do that sodium sulfide example. So you want to weigh out 2.84 moles of your sodium sulfide. What is that mass in terms of grams? Okay, unit conversion, start with what you know. Oh, what's sodium sulfide? You You should know that from your naming. And if that's still giving you a hard time, I suggest that you go back and look at lecture 1.2. The last, I think, parts 3 and 4 would help you. Now we need to calculate number of grams. So here we're going to have to calculate the molecular weight of sodium sulfide. There are 2 sodiums, and sodium is 22.99 grams per mole. And sulfur is 32.06 grams per mole. So after you do that math, you should get 78.04 grams per mole as your molecular weight of sodium sulfide. Does that number, that 78.04, go on the top or on the bottom? Well, let's think about it this way. Does the mole go on the top or on the bottom? On the bottom. Remember, that's always per 1 mole. So that means that this number goes on the top. And then all you have to do is do your calculation. And you'll see that 2.84 moles of sodium sulfide is equal to, or weighs, 222 grams. Do you have the right number of sig figs? Yes. Okay, now when I looked at your book in the very end for the homework, I noticed that for 17, 18, and 19, they all call molecular weight something different. Molecular weight is the same thing as formula weight. That's abbreviated FW. There's MW, and molar mass is abbreviated cursive M, or italicized M. The reason they're called all these different things, molecular weight is the weight of the molecule, and you can't take a molecular weight of an ionic compound because ionic compounds aren't molecules. So then we use the term formula weight. And molar mass is just a completely different term altogether. So don't be confused, they all mean the same thing. They all mean grams per mole. Okay, let's talk now about I'm going to start that in a new movie.